So we're going to go through the quiz real quick here. There will be a real quick worksheet to follow. Please make sure you watch the entire video and then complete the worksheet, and this will take place the quiz corrections. Okay, the first example, a lot of mistakes here, and this problem some students made a little harder than it needs to be. Um, when we look at this, a lot of people were distributing or foiling. But there's no addition here. This is straight multiplication. All you had to do was multiply these outside numbers. 3 times 3 is 9. Then root 10 times root 10. You could basically consider root 100, which is the same as 10. And 9 times 10 is 90. Okay? That's all you had to do. There's no foiling involved because there's no addition. Okay? Now the next one, you are doing, you're distributing this 2 root 5. And what you have to remember is these outside numbers multiply with outside numbers, and the inside numbers multiply with inside numbers. So when we multiply this, 2 times 2 is 4, and root 5 times root 5 is going to give you root 25, and this basically just becomes 4 times 5, which is 20, and now you're going to do 2 root 5 times root 32. Now, sometimes I'll make this a smaller number, right? By doing root 16 times root 2, I'll simplify it. It gives me 4 root 2. Now, when I do 2 times 4, I get 8. Then root 5 times root 2 is root 10. Okay, it just allows me to do it easier in my head because it's working with smaller numbers. Okay, you could do 2 and then root 160 and then simplify 160 and you get the same thing. Okay, third example. In order to get rid of the radical in the denominator, we have to rationalize it. How do we do it? We multiply numerator and denominator by root 5, right? Because that's the radical we need to get rid of in the denominator. Now up top, I have to distribute this root 5. So 3 times root 5 gives me 3 root 5. Then root 2 times root 5 is plus root 10 all over root 5 times root 5 is root 25, which simplifies to 5. Now this, if I look, I have an outside number 3, an outside number 1, and an outside number 5. Can those three numbers be simplified? No. Therefore, we leave our answer like this. Okay, now the next one. Yes, we have a radical in the denominator. Okay, but it's basically, a whole number minus some rational number, right? Or irrational number, sorry. So anytime this happens, we have to multiply by the conjugate of this, all right? So we have 1 plus root 7 is the conjugate. I'm going to multiply the numerator by 1 plus root 7. Now, up top, this is where I'm going to have to FOIL. So 3 times 1 is 3. 3 times root 7 is plus 3 root 7. Then minus root 2 times 1 is root 2. And then minus root 14. Now, if I look at that numerator, nothing can be simplified, so I leave it as is. Okay, nothing. Root 7 can't be broken down, and root 14 cannot. Now, in the denominator, because I know they're a difference of 2 squares, all I really have to multiply are the first and last terms. And that's going to give me 1 times 1 is 1. Then root 7 times root 7 is going to be minus 7. 1 minus 7 is negative 6. I did accept this answer, okay, but you could divide everything by negative 1 and get negative 3 minus 3 root 7 plus root 2 plus root 14 all over positive 6. Both of these answers were accepted. Number 5 was probably the easiest problem on the quiz. Remember, if there's no number in front, we picture it being a 1. And if I look, root 6 and root 6, these are like radicals. Therefore, all I do is add or subtract the numbers in front. So 1 minus 13 is negative 12. And then I bring down the root 6 with it, and I am done. Remember, you're subtracting those two terms, and you're basically combining like radicals. Now, number 6, before we can move on, we actually have to simplify these radicals. So this is going to give me 3 times root 36 times root 2. This is 3 times 6, which is 18 root 2. And the second one is 5 times root 16 times root 2. And this becomes 5 times 4, which is plus 20 root 2. And now when I combine the like radicals, 18 plus 20 is 38. And then I bring the root 2 down. Now, when we get to these complex numbers, you have to know what the operation is. Okay? In this first one, we are basically subtracting. Okay? Therefore, all I have to do is bring down these two terms, negative 2 plus 15i, but then I have to distribute the minus sign, which just changes the signs inside here. So a negative times a positive 8 is minus 8. A negative times a negative 3i is plus 3i. Now all I have to do is combine like terms. Negative 2 and negative 8 are like terms. 15i and 3i are like terms. So negative 2 minus 8 is negative 10. 15i plus 3i gives me plus 18i. And I am done. Okay. Now the next one, 5i times negative 3 gives you negative 15i. Then 5i times 12i is going to give you plus 60i squared. Remember, I times I is I squared. But what you have to remember is anytime you see I squared, you can replace it with negative 1. So this is the same as doing 60 times negative 1, which gives me negative 60. And then I have to bring down the minus 15i. Now, a lot of people saw that this could be reduced, but we don't want to reduce this because we don't have a denominator. And we don't want to factor anything out because it's pointless because we just multiplied it out. So we will leave it as is. Now, number 9, when we FOIL these complex numbers out, 7 times 8 is 56. 7 times 6i is going to give you plus 42i. And now I'm going to distribute the negative 4i. So negative 4i times 8 is minus 32i. And then negative 4 times 6i is minus 24i squared. Now, the thing you have to know here is this here is going to change. So the 56 stays the same. I'm going to combine these, right? And that's going to give me plus 10i. But then I have to remember this is negative 24 times negative 1, which changes it to a positive 24. 56 plus 24 is 80 plus 10i. And we stop. We do not factor anything out from here. Okay? That's the end of the problem. Number 10. Now I have a complex number in the denominator. That's the same thing. This I tells me I basically have a radical in the denominator. So this is where we multiply by the conjugate of this. So you know the first and last terms are the same. The only thing is instead of being linked by addition, we're going to subtract. So the middle term cancels out. What we multiply the denominator by, we multiply the numerator by. So 8i times 1 is 8i. 8i times negative 5i is going to give me minus 40i squared. So what this numerator becomes, this is the same as doing negative 40 times negative 1. So you get positive 40 and then plus 8i. So that's your new numerator. sorry, 40 plus 8i. Now the denominator, again, I can FOIL this out, but you should know you can get away with the first times the last. If I FOIL it out, 1 times 1 is 1, minus 5i, plus 5i, and you see these eliminate right away, and then minus 25i squared. But this changes to negative 25 times negative 1, so it's 1 plus 25, which gives you 26. So when we multiply this denominator out, we get over 26. Now, if I look at these three terms, if I look at 40, 8, and 26, those all can be divided by a common number, and that common number would be 2. And if I divide everything by 2, 40 divided by 2, 20, plus 8i divided by 2 is 4i. All over 26 divided by 2 is 13. And this is the best answer that you can give. Okay? Now, number 11. All you had to do here was multiply by I. All right? Now, you can multiply by 8i, but you're just going to have a lot more simplifying to do. So anytime you just have a number times I in the denominator, is multiply by I. So that would give me 4i plus 2i squared all over 8i squared. So to simplify this, right, you know this will become 2 times negative 1. This will become 8 times negative 1. So we end up with, in the numerator, negative 2 plus 4i. Remember, we always want to write it, the integer plus or minus the imaginary number, all over 8 times negative 1 is negative 8. But if I look, this 2, this 4, and this 8 can all be divided by, and because 8's negative, I prefer we divide by negative 2. So if I divide each of these by negative 2, right? So what we would get here is negative 2 divided by negative 2 is positive 1. 4 divided by negative 2 is minus 2. I, all over negative 8 divided by negative 2 is 4. And there's your best final answer. Okay, the last one here, what we're going to do is we're going to multiply by the conjugate of the denominator. Remember, the first and last terms stay the same. We change subtraction to addition. So we're going to multiply the numerator and denominator by the conjugate of the denominator. Now we're going to FOIL the numerator out. That's going to give me 3 times 1 is 3. 3 times 2i is plus 6i. Negative 5i times 1 is minus 5i. And then negative 5i times 2i gives you minus 10i squared. But this can be simplified. So what does this become? Negative 10 times negative 1. So my numerator now will be 3 plus 10 is 13. 6i minus 5i is plus 1i. All over my denominator now. 1 times 1 is 1. Negative 2i times 2i, it gives me minus 4i squared. But that becomes 1 plus 4, so it's all over 5. And there is our answer. Okay, so I hope this helps. If you have further questions, you can always come in period 2. But hopefully it helped and get the other worksheet done. Have a good night.